Hi, in this class, we are going to be discussing Probability and Stats paper one, S1 paper, October-November 2023, variant 5.3. The first question is, Becky sometimes works in an office and sometimes works at home. The random variable X denotes the number of days that she works at home in any given week. It is given that probability that of X equals to X is given by this formula Kx times X plus 1, where K is a constant and X is equals to 1, 2, 3, and 4 only. For the first part, we have been asked to draw a probability distribution table for X, given the probabilities as a numerical fraction. Okay. So first we have to draw a probability distribution table. The possible values of X are going to be 1, 2, 3, and 4. We need to find the probability that X is equals to X. Okay, so what is the probability that X is equals to 1? Okay, so the first probability that X is equals to 1, that's going to be K times 1 times 1 plus 1, that is 2K. Probability that X is equals to 2, that's going to be 6K. Probability that X is equals to 3, just plug in the value of X as 3 and we are going to get 12K. Probability that X is equals to 4, that's going to be 5 times 4, 20K. Now, the sum of the probabilities is always equals to 1. So this result is always equals to 1. So isko jab solve karenge aap, so that's going to give you the value of K. 20 plus 12 plus 6 plus 2, that's 40. So K value comes out to be 1 upon 40. So probability that X is equals to 1 is going to be 2K, that's 2 upon 40. Probability that X is equals to 2 is 6 upon 40. X equals to 3 is 12 upon 40, and that's going to be 20 upon 40. Okay, we need to give the answer as the numerical fractions. Now, part B says, find the expected value of X and the variance of X. Okay, expected value of X is calculated as sigma XP. We are going to multiply the X values with the probabilities. So that's going to be 1 times 2 upon 40 plus 2 times 6 upon 40 plus 3 times 12 upon 40 plus 4 times 20 upon 40. So we are going to get E of X as 13 upon 4. Okay. For variance of X is defined as sigma X square P. So we are going to take the X square values and we are going to multiply with the probabilities. So X cube values, X square values are going to be 1, 4, 9, and 16. E of X square is sigma X square P minus E of X sigma XP, the whole thing square. So 1 times 2 upon 40 plus 4 times 6 upon 40 plus 9 times 12 upon 40 plus 16 times 20 upon 40. That is E of X square minus E of X, that is 13 upon 4, the whole thing square. Solving this will give us the value of the variance. So the variance comes out to be 63 upon 80. That is 0.7875. This is E of X and that's the variance. Moving on to question number 2. The weights of a large bags of pasta produced by a company are normally distributed with mean 1.5 kg and standard deviation 0.05 kg. Find the probability that a randomly chosen large bag of pasta weighs between 1.42 and 1.52 kg. Okay. So इस question में X represents weights of a large bag of pasta. And it follows a normal distribution with mean 1.5 and a standard deviation of 0.05 square. In this question, we need to find the probability that X is greater than 1.42 and less than 1.52. If I draw a bell curve, normal distribution curve, this is the mean 1.5. The value of 1.42 is below the mean and 1.52 is above the mean. We need to find this area or the probability associated with this area. So firstly, we are going to find the Z value. So probability of Z greater than the corresponding value of 1.4, corresponding Z value of 1.42 would be 1.42 minus 1.5 divided by 0.05, 1.52 minus 1.5 divided by 0.05. All right, so the Z value comes out to be minus 1.6 and 0.4. Okay, so this value is minus 1.6 and 0.4. So we're going to go to the table, normal distribution table, and read the body area at 1.6 at a Z value of positive 1.6, and we are going to read the body area at a Z value of 0.4. Okay. Okay. 1.6 is 0.9452 and 0.4 is 0.6554. So the body area at 0.4 is 0.6554 and the body area at 1.6 was 0.9452. To find the area between, you're going to add the probability 0.6554 plus 0.9452 and subtract 1. So the area comes out to be 0.601. Okay, that's this area. Part B में, the weights of small bags of pasta produced by a company are normally distributed with mean 0.75 kg. So now X represents mass weights of small bags of pasta. And this follows a normal distribution with mean 0.75 kg and the standard deviation of sigma square. Okay, it is found that 68% of the bags have weight less than 0.9 kg. So if I draw a bell curve, the mean is 0.75. The value of 0.9 is going to be over here. All right, it is given that 60% of these bags have a weight less than 0.9 kg. So if probability that a bag is going to have a weight less than 0.9 kg is 0.68. So that's the body area 0.68. Now it's a reverse question in which the probability or the body area is given and you're going to find the corresponding Z value. Okay, so we are going to go back to the table and read the Z value, find the Z value at 0.68 body area. 0.68 is the probability. Okay, we have 0.6772. Okay, and we need to add 8. We need to add 10. So the closer one is 11. So we are going to take the z value of 0 0.46, 0 0.463, 0 0.46 and 3. Oh, sorry, my bad. We need to add 28, not 8. So for 28, the closest value would be 29. So it's going to be 0 0.4, 0 0.46, and 8. That is going to be the z value, 0 0.468. So the corresponding z value for this is going to be 0 0.468. Z is equals to 0.9 minus 0.75 divided by sigma, which is 0 0.468. Solving this will give us the value of sigma. And this comes out to be 0 0.321. Question number 3. Tim has 2 bags of marbles A and B. Bag A contains 8 white, 4 red, and 3 yellow marbles. Bag B contains 6 white, 7 red, and 2 yellow marbles. Tim also has an ordinary fair 6-sided dice. He rolls the dice. If he obtains a 1 or a 2, he chooses 2 marbles at random from bag A without replacement. If he obtains 3, 4, 5, or 6, he chooses 2 marbles at random from bag B without replacement. Find the probability that both marbles are white. So both marbles can be white from bag A or from bag B. So probability that both marbles are white is going to be probability that it's from bag A or it's from bag B. Now, go back to the question again. Bag A contains 8 white, 4 red, and 3 yellow marbles. Now, he is deciding which bag to choose with the help of a dice. If the die lands on 1 or a 2, he chooses bag A. So if we are picking up bag A, the probability of choosing bag A would be 2 upon 6, because we are going to choose bag A with either having 1 on the dice or 2 on the dice. That's 2 outcome out of 6 on the dice. So the probability of choosing a bag A would be 2 out of 6. Then he is selecting white marbles. There are 8 white marbles and the total are 15. And this is being done without replacement. So the next white marble he's going to pick from bag A will have a probability of 7 upon 15. For bag B, the probability of choosing bag B is 4 out of 6. There are 6 white marbles out of 15. And this is also being done without replacement. So 5 out of 14. That's the probability. Add them up. This is going to be 14. So we get 58 upon 315, which in decimal is 0 0.184. So 0 0.184 is the probability. Now, part B says, find the probability that the 2 marbles come from the bag B, given that 1 is white and 1 is red. So it's a conditional probability. Probability that the 2 marbles come from bag B, given that 1 is white and the other one is red. This is going to be equal to the probability of having a white and a red marble in the denominator. And in the numerator, it has to be from bag B, and one has to be a white and one has to be a red marble. Now think of a tree diagram. The best way to go about these questions is to understand the tree diagram. First, we were selecting the correct bag. Probability of selecting bag A was 2 out of 6. Probability of selecting bag B was 4 out of 6. If bag A was selected, then we are either going to have a white or a red marble. White, red, and yellow. There are three possibilities. White, red, and yellow. Okay. And white, red, and yellow. Okay. Now, if the first was white, the second could have been white, red, yellow, white, red, yellow, white, red, yellow. Okay. Now, I'm not going to write all the probabilities, but this is the tree diagram. Now, the question says that the denominator should have the probability of having a white and a red marble. The white and a red marble can either be from bag A or it can be from bag B. So the probability would be, if it is from bag A, so first you select bag A, the probability is 2 out of 6. There were 8 white marbles and 4 red marbles in bag A. 8 white marbles probability and 4 red marbles. Okay. So 2 upon 6 times 8 upon 15 times 4 upon 14. That's one case. Okay. Plus, it can be red and a white as well. Okay. It can be from bag A and it can be red and a white. So I can multiply it by 2. Then if it is from bag B, first you will have to select bag B. The probability of selecting bag B is 4 upon 6. Then there are 6 white marbles and 7 red marbles. So 6 upon 15 times, there are 7 red marbles, 7 upon 14. Okay. Now we can have red first, then white as well. So I'm going to multiply this probability by 2. And in the numerator, we'll have the probability that we are selecting white and a red marble from bag B. So in the numerator, we are going to have 4 upon 6 times 6 upon 15 times 7 upon 14. And it can be both ways. So times 2. Solving this will give us the conditional probability. So let's solve it. So for the numerator, I get 4 upon 15. For the denominator, I get 116 upon 315. And if you divide this, you get 21 upon 29. That is 0.724. That's the answer for the part B. Okay, question number 4. The weights kg of 120 students in a sports college are recorded. The results are summarized in the following table. हमें weights की upper boundary given है. Okay, and we have the cumulative frequency. These are the exact points that you're going to plot on a cumulative frequency graph. So vertical axis is going to be for cumulative frequency. Horizontal axis is going to be for the weights in kg. This is cumulative frequency. The smallest value is 40 and highest value is 100. Start with 40, 50, 60, 70, 80, 90, and 100. The vertical axis has to go from 0 to 120. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay, so the first point is 40, 0. The next point is 60, 14. Then 65, 38. This is 65, 65, 38. Then 70, 60. Then 85, 106. 85, 106. And 100, 120. Join the points using a smooth curve. All right, now that's our cumulative frequency graph. Part B says it is found that 35% of the students weighed more than WKG. Use your graph to estimate the value of W. So 35% of the students weigh more than WKG. So that means 65% of students weigh less than WKG. So calculate 65% of the total cumulative frequency. 65% of 120 is 78. And we are going to go and read the value at 78. So this is 78. So this is 75 and this is 76. So roughly between 75 and 76 from my graph. So 75.5 kg. The answer of 76 would have been acceptable as well. Okay. Then part C says calculate estimates for the mean and the standard deviation of the weights of 120 students. Uske liye you will be needing this table that I'm going to copy on the next slide. From this table, you all are going to make a frequency distribution table. Okay. So the first interval is going to be from 0 to 40. The next interval is greater than 40, less than equal to 60. Next interval is greater than 60, less than equal to 65. Then the next interval is greater than 65, less than equal to 70. Then x is greater than 70, less than equal to 85. And then the final interval would be x greater than 85, less than equal to 100. Okay, now for the frequency, there were no students who weighed less than equal to 40 kg. There are 14 students who weigh between 40 and 60. There are 38 minus 14, there are 24 students. 60 minus 38, 22. 106 minus 60, that's 46. And 120 minus 106, that's 14. Now we have the frequency distribution table. Then we are going to find the mid value of each interval, 20. That's going to be 50, 62.5, 67.5, 77.5, and 92.5. Now to calculate the mean, we are going to use sigma fx over sigma f. 20 times 0 plus 50 times 14 plus 62.5 times 24 plus 67.5 times 22 plus 77.5 times 46 plus 92.5 times 14 divided by the total frequency, that is 120. So I get 85 0.45 for this divided by 120. In decimal, that comes out to be 71.2. That's the mean. To find the standard deviation, we'll first have to find the variance. Variance is defined as expected value of x square minus the square of the expected values. Okay, so 20 square times 0 plus 50 square times 14 plus 62.5 square times 24 plus 67.5 square times 22 plus 77.5 square times 46 plus 92.5 square times 14. This is E of x square minus E of x, the whole thing square, which is the mean, that is 71.2 square. All right, solving this will give you 138.23. Now the standard deviation is the square root of the variance. So square root of this answer is 11.75, which is 11.8. That's the working for the standard deviation and the mean. Okay, question number 5. The probability that a driver passes an advanced driving test is 0.3 on any given attempt. Deepak keeps taking the test until he passes. He keeps on taking the test until he passes. The random variable x denotes the number of attempts required for Deepak to pass the test. Find the probability that x is greater than equal to 2, less than equal to 6. This would mean x equals to 2, x equals to 3. He passes in the third attempt, or he passes in the fourth attempt, or he passes in the fifth attempt, or he passes in the sixth attempt. Okay. So either we calculate these individual probabilities, okay, or what we can do is we can take out the probabilities of x less than equal to 6, x less than equal to 6, and we can take out the probabilities of x less than equal to 1, and we can subtract that. Because over here, there's only one outcome, that is probability of x equals to 1, which if subtracted from x less than equal to 6, give us all of this answer. So it's a geometric distribution question. In a geometric distribution question, probability of x less than equal to r is 1 minus q to the power of r. So what I can do is I can calculate the probability of x less than equal to 6 and then subtract the probabilities of x less than equal to 1 from that to calculate the probability of from 2 to 6. So probability of x less than equal to 6 is 1 minus q to the power of 6, and q is the probability of the failure. If the probability that he's going to pass is 0.3, then the probability of failure is 0.7 minus probability of x less than equal to 1. X less than equal to 1 means 1. Okay, so probability of x less than equal to 1 means that he passes in the first attempt, that is x equals to 1, so that's 0.3. So 1 minus 0.7 to the power of 6 minus 0.3, that's 0.582. Now the second part says find E of x. E of x for a geometric distribution is 1 upon p. And 1 upon p is 1 divided by 0.3, and 1 divided by 0.3 is basically 10 upon 3. Now, part B says 5 friends will each take their advanced driving test tomorrow. Find the probability that at least 3 of them will pass tomorrow. So there are 5 friends who are going to take. So if I say X represents the number of friends who pass, the test tomorrow. So there are fixed attempts, that is 5, and the probability that the trials are independent because probability that a friend is going to pass does not depend whether his friend is going to pass or not. So the trials are independent. So probability of success over here is going to be 0.3. We need to find that probability that at least 3 of them is going to pass. So to find the probability of at least 3, what we can do is we can take out the probabilities of 3, 4, 5, or we can take out the probability of 0, 1, 2 and subtract from 1. So both working are correct. So we need 3, probability of 3, probability of 4 friends, and probability of 5 friends passing. Probability of 3 friends passing is going to be 5C3 times 0.3 to the power of 3, 0.7 to the power of 2. 5C4, 0.3 to the power of 4, 0.7 to the power of 1. 5C5, 0.3 to the power of 5, 0.7 to the power of 0. Calculate all these probabilities and you're going to get your answer. So you get 0.163. Now, part C says 75% people will take their advanced driving test next week. Use an approximation to find the probability that more than 20 of them will pass the test next week. Okay, again, X represents the number of people who are going to pass the test. But here, the number of trials is a lot. And we need to find so many probabilities. So we are going to check the suitable approximation that we are going to use is the normal approximation. First, always check if the condition for a normal approximation are valid or not. So we are going to calculate NP and NQ. Over here, the number of attempts, the number of people are 75, and the probability of success is 0.3. So 75 times 0.3 and 75 times 0.7 is definitely greater than 5. So we can go for normal approximation. To use normal approximation, I'll have to calculate the mean, and the mean in a normal approximation is calculated as NP, that is 75 times 0.3, which is 22.5, and the variance is NPQ. So that's 15.75. Okay, so that means the normal distribution parameters are going to be 22.5 comma square root of 15.75 square. The standard deviation is square root 15.75. We need to find the probability that more than 20. So we have to do a continuity correction over here. So we are going to take X greater than 20.5. So if I draw the bell curve now, the mean is 22.5. I want to find greater than 20.5. 20.5 value is going to be towards the left side of the mean. Okay, so first let's find the Z value. 20.5 minus 22.5 divided by sigma, that's 15.75. So probability that Z is greater than, calculate this, minus 0.504. Now this value is minus 0.504. We need the body area over here. We are going to go back to the table and read the body area at the Z value of 0.504. 0.5, 0, and 4. So that's going to be 0.6915 plus 0.0014. So we get 0.6929. Okay, 6929. So this comes out to be 0.6929. 6929. Three significant figures is going to be 0.693. Okay, that's the working for question 5, part C. Moving on, question number 6. Jay and his wife Kaz are having a party. Jay has invited 5 friends and each friend will bring his wife. So he has invited 5 friends and each is going to bring his wife. At the beginning of the party, 12 people will stand in a line for a photograph. How many different arrangements are there of the 12 people if J stands next to Kes and each friend next to his own wife. Okay. So there are 12 people 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. J is going to stand with his wife Kes. Okay. So, and each person is also going to stand with his own wife, and they have to stand in a line. Okay. J stand next to Kes and each friend stand next to his own wife. So there are going to be 6 couples, and these 6 couples can arrange themselves in 6 factorial ways. And each couple can rearrange themselves in 2 factorial ways. For example, J and Kes can swap their places in 2 factorial ways. The other couples can also do the same thing. So it's 2 factorial to the power of 6. That is simply 2 raised to the power of 6. So 6 factorial times 2 to the power of 6, that is 46080. Part 2 says, how many different arrangements are there of the 12 people if J and Kes occupy the 2 middle position in the line with J's 5 friends on one side and 5 wives on the other side? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. J and Kes are going to occupy the middle position. And J's 5 friends are going to be over here, and Kes, like the wives are going to be on the side of Kes. Okay. So that means first we have 2 options for J and Kes. J and Kes. That so they can arrange in 2 factorial ways. Now let's say one of the possibility is this J is over here and Kes is over here. So let's say they are fixed now. These 5 can arrange in 5 factorial, and the 5 wives can arrange in 5 factorial ways. Right? How many different arrangements are there of the 12 people if J and Kes occupy the 2 middle positions in the line with J's 5 friends on one side and the wives of the friends on the other side? Okay, so now the question also says that these 5 people and these 5 people can also swap their places. Okay, so you need to multiply this by 2 as well. So the final answer would be 2 factorial times 5 factorial times 5 factorial times 2. That is 57,600 total arrangements possible. For a competition during a party, the 12 people are divided at random into groups of 5, a groups of 4, and a group of 3. We need to find the probability that J and Kaz are in the same group as each other. So the 12 people are divided at random into the groups of 5. Okay, so J and Kaz can be in group of 5, can be in group of 4, and can be in group of 3 as well. So if they are in group of 5, so 1, 2, 3, 4, 5. If J's and K's are in the group of 5, then okay, they have to be in the same group. Okay, so we need to find the probability that J and K's are in the same group. Okay, if they are in this group, then what we can do is, okay, so we have group of 5, group of 4, and group of 3. And there are a total of 12 people. So okay, So J and K's have to be in the same group. They can be in any other group. Let's say if they are in the group of 5, then okay, so J and K's have to be in the same group as each other. Now, this means that there's a group of 5, there's a group of 4, and there's a group of 3. First option is that J and K's are in the group of 5. The second option is that they are in the group of 4. And the third option is that they are in a group of 3. Okay. Now, let's find out the possibilities. If J and K's are in group of 5, then out of the remaining 10 people, any 3 people can come over here. And out of the remaining 7 people, any 4 people can go in group 4. And out of the remaining 3 people, any 3 people, all 3 people have to go in group 3. Okay. If they are in a group of 4, then out of the remaining 10 people, any 2 people can go in group of 4. And out of the remaining 8 people, any 5 people can go over here, and out of the remaining 2, all 2 people will go in the group of, sorry, out of the remaining 3 people, all 3 people are gonna go in group of 3. And if J and K's are in group of 3, so out of 10 people, any 1 people can go in a group of 3. So that can be done in 10C1 ways. And out of the remaining 9, any 5 people can go in a group of 5, and then the remaining 4 people will go in a group of 4. So let's find out all the possibilities. 10C3 into 7C4, that's 4200. 8C5 into 10C2, that is 2520. And 9C5 into 10, that's 1260. This makes up a total of 7,980 combinations in which J and K's are going to be in the same group. Okay, but we need to find the probability. So to find the probability, we are going to divide it by the total outcome. So 7980, the total divided by the total number of possible, total number of ways of arranging the 3 groups. Okay, now if there wasn't any restriction, then out of the 12 people, any 5 people can go in the first 5 group of 5. Then the remaining out of the remaining 7 people, 4 people can go in the group of 4. And out of the remaining 3, all 3 will go in the group of 3. So 12C5 times 7C4 is 27,720 possible combinations. So the probability that J and K's are going to be in the same group is going to be 7,980 divided by this value. So I'm going to get 19 upon 66, which in decimal is 0.2878, which is 0.288. That is the possible probability. Thank you.